Good afternoon, everyone. We are the Office of Environmental Health Hazards Assessment Team, and today we're going to be presenting our findings on warehouse-related emissions in Southern California. So this is our team and our advisor, Professor Saide, and our OEHHA client partner, Laurel Plummer, with whom gave us the privilege of presenting our findings to OEHHA and CARB staff yesterday as well as today. So as warehouses, as fast shipping and ultra convenience arise in the United States, more warehouses have sprung up to meet this crazy demand. This requires more truck trips to move goods around to and from all of these warehouses. This heightened respiratory and cardiovascular risk from PM2.5 exposure. And so by electrifying the zero emission trucks, we are able to decrease these risks. So our project focuses around two research questions. The first is, how does the distribution of warehouse locations disproportionately impact the air quality and health of racially and socioeconomically marginalized communities? And two, how can the electrification of heavy-duty diesel trucks improve the quality and health of communities living in close proximities to these warehouse locations? Our project is concerned with three pieces of legislation. The first is the WARE program, which is a point-based system incentivizing warehouses to report and reduce emissions. The second is ACF, which stands for Advanced Clean Fleets. This mandates that 100% of heavy-duty trucks in CARB-regulated fleets must be transitioned to zero-emission vehicles by 2042. And the third is ACT, which stands for Advanced Clean Trucks. This requires manufacturers to ensure that at least 40% of new heavy-duty truck sales are zero emission by 2042. The figure on the right here shows the difference between ACT and ACF, and you can see here the emissions drop pretty drastically under the ACF regulation. So these three pieces of legislation form the basis of our project scenarios. So these are our 5 project scenarios. The first scenario forms the baseline scenario of current day Southern California without any emissions reductions due to regulations. The second scenario factors in the WARE program on the baseline emissions, which will estimate how mitigation actions will reduce pollution on top of the baseline scenario. The third scenario projects ZEV adoption under CARB's ACF rule with a fleet composition of 100% ZEVs being achieved in 2042. And scenario 4 follows CARB's ACT rule and assumes 46.1% of ZEV adoption by 2042. The last scenario assumes that no ZEV mandates are adopted and that fleets remain primarily powered by internal combustion engines by 2042. This is a very relevant scenario for today because recently in May, the Senate voted to overturn California's ZEV mandates for trucks and for passenger cars.
To give you an overview of our methods, we use the publicly available warehouse city data to obtain warehouse locations and size information. We then proceeded this dataset in RStudio to generate our emissions file for each of our scenarios for the 5 pollutants we're analyzing: PM2.5, NOx, SOx, NH3, and VOC. Next, we use the EcoAir model in Jupyter Notebook to simulate air quality impacts. EcoAir is especially useful in estimating both secondary PM2.5 emissions and associated health impacts. And finally, we use the outputs from EcoAir along with Cal environment data screen dataset to conduct an environmental justice analysis in RStudio. This helped us assess how air quality may disproportionately affect communities that are already vulnerable. And now looking at the results, Cal Environment Screen score reflects cumulative environmental and social burdens, where higher score indicates more vulnerable communities. As shown here, areas such as Los Angeles, Pomona, Ontario, and Riverside have clusters of high vulnerability. These tracts are often surrounded by similarly disadvantaged neighborhoods, reinforcing regional concentration of vulnerability. In scenario 1, population-weighted PM2.5 exposure spans a wide range. But even at these low concentrations, long-term exposure can still contribute to serious health impacts. 3 major exposure hotspots emerge. Number 1 here, San Bernardino to Riverside. Number 2, South and East LA. And number 3, Lake Forest. These areas align closely with both warehouse activities and high social vulnerability. Under scenario 3, which models full zero emission truck adaptation by 2042, PM2.5 exposure drops dramatically. Most areas fall within the lowest concentration range, and even the hotspots are greatly reduced compared to scenario 1. This highlights the significant public health and equity benefits of aggressive CEV adaptation.
Okay, so now let's look at a bar chart that shows the population-weighted PM2.5 concentrations for each scenario. So first here we have scenarios 1 and 2, our base, and the other one, scenario 2, showing the impact of the WARE program. And as we can see, there's only a slight difference between the two, basically telling us that the WARE program does not have a huge impact on emissions. And then so now let's look at the bar graph for scenario 4, our ACT regulation, and how this looks between 2035 and 2042. So here the green bar represents our projection for 2035, and then the purple for 2042. And as we can see with the ACT regulation, we only see a slight decrease in the concentration between our base year and our future projected years, which more or less suggests that the current regulations do not necessarily reduce, but only keep emissions from worsening. And then now let's look at scenario 5, which is again our scenario without any regulation. And as we can see, there's obviously this huge increase in emissions, and through both years, 2035 and 2042, compared to our current emissions. Again, emphasizing this importance of having any sort of regulations, because without them, it would only exacerbate exposure over time. And then finally, let's go back to scenario 3, which again is the most aggressive scenario. Again, having that widespread 100% ZEV adoption. And there's this huge decrease in emissions compared to the rest of the scenarios, showing the effectiveness that this regulation has on the outcome of emissions. And then now finally, let's look at the population-weighted PM2.5 emissions per scenario and compare them to our Cal and virus screen quartiles. Specifically, this graph focuses on quartiles 1, which is the orange, and then quartiles 4, which is the purple, which coincide with the highest and lowest burden communities due to the socioeconomic and health factors. Quartile 1 being the lowest impacted, and then quartile 4 being the highest impacted. And from this graph, it's important to note that the percent difference between the most and least burden communities, quartiles 1 and 4, remains at least a baseline of 64%, and it even gets to around 76% in our scenario 5, which is again our scenario without any regulation, basically indicating the persistent or growing inequality and emission exposure. Now, notably in scenario 3, with 100% ZEV adoption by 2042, it shows the greatest reduction in emissions for both quartiles, and it's especially notable to look at that there is a 91% decrease for the most impacted communities. Again, this underscores the need for targeted policies that both reduce emissions and address equity. And finally, we have a couple recommendations for our project. Just for time's sake, the most notable ones are we would want in the future to expand our project to statewide analysis, and then we would also like to conduct real-time monitoring to validate models and track progress. But yes, this concludes our findings for the project. If you have any questions or recommendations, we'd be happy to answer them.
Questions from the audience? Yeah, no, please.
Yeah, so thinking about like the long-term effects of using so many batteries for these EV trucks, was there any analysis or studying to do? What about the disposal of them, and where would the disposals be, and what impact the environment would that be?
So for our project, we didn't focus on like disposal of ZEV batteries. That was outside the scope of our project. But I can tell you we did still look into like ZEV trucks still do produce PM2.5 like PM2.5 emissions through like brake wear and tire wear, and that's something we looked at. But yeah.
So why is the Inland Empire so high? Why are San Bernardino rivers not so high? Is it just because there's more warehouses and more trucks, or is it drift, or is it, what is it?
So that's probably the highest concentration of warehouses in the state, in the Inland Empire. if you were to look at Google Maps on like a satellite view, it's pretty obvious how many warehouses there are, and they're not just, these are very large warehouses too, so that's why you see the highest concentrations of emissions there, is simply just because that's where the most warehouses are.
It's not the air patterns.
And also it's where land is available and you have the highest growth rate of warehouses. I mean, it's just astounding how much infill is going on there. Yeah,
Are there any, I mean, how, do you know what percentage of the fleet is electric truck at this point? Any, is 0% or is it more than that?
It's-
6 point.
Yeah, 6.1%,
Really?
yes.
is that largely used in more local transportation or is that long haul trucking, if you know?
It's in heavy duty trucks. I think that's the best way actually.
Yeah, excellent. All right, well, thank you so much, team. This is